Hi everybody. So in this video, we're going to look at the arc length of a sector. So we'll work through a few examples and then we'll try some exam style questions. And if you want to work along with me, you can download this PDF from my website. I'll leave a link below. So in the first example, I want to show you how we create the formula for the arc length of a sector. The arc length is from A to B from this sector, okay? So it's the part of the circumference that encloses the two radii. So the way we find this arc length is that we consider the full circle. Now we know that the full circle has a circumference of pi times the diameter, and the arc length is a fraction of this entire circumference. The fraction is this angle theta out of the entire circle, which has 360 degrees. So the arc length, which we call L, will be the fraction of theta over 360 of the entire circumference, which is pi d. So this is the arc length in terms of diameter, but we can write this in terms of a radius. We know two radii give us the diameter, so we could say that L will be theta over 360 times pi times 2 lots of a radius. And then we can simplify this. We'll divide this by 2 and this by 2. So we get L will equal theta over 180 times pi r. Okay, so throughout this video, we're going to use either of these two formulae for the arc length of a sector. If we look at the next example, so in example 2, we've been given the sector A or B. We've been asked to work out the length A to B, which is the arc length. So again, I'll label this L. So the arc length will be the angle, this is 60 degrees, over the entire circle, 360, multiplied by pi, multiplied by the diameter, which is 2 lots of this radius, so times 24, okay? So in this example, I'm using this version of the equation. And we can simplify this fraction. We can divide both by 60, so L would be 1 over 6 multiplied by pi and 24. And then we can divide the 24 by 6, and we'll get the arc length is 4 pi. Then we can work this out on our calculators, and we get the arc length as 12.57 centimeters to 2 decimal places. Okay, let's try example 3. So now we've been given the sector with a radius of 30 centimeters and an angle of 240 degrees. And again, we need to work out the length of AB now to 1 decimal place. So do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so if we say the arc length is L, and we know this is the angle 240 divided by the full circle, 360, multiplied by pi, multiplied by the diameter, and the diameter would be 2 lots of this radius, so 60. We can simplify this fraction. We'll divide both by 120, so we'll get 2 over 3 times pi times the 60. And 1/3 of 60 is 20. We'll double that, so we get 40 pi. And this will be in centimeters. To convert that to a decimal, we get 125.66. But to 1 decimal place, this would be 125.7 centimeters to 1 dp. Okay, how did you get on? Let's try another example. So in our next example, we've been given the sector with a radius of 9 centimeters and an angle of 140, and we've been asked to work out the perimeter, which is the distance around the entire edge. And we need to leave the answer in terms of pi. So do you want to give this question a go? You can come back when you're ready. Okay, so welcome back. So if we label the arc length L, this will be the angle over 360, and the fraction of a full circle, which is pi times the diameter would be double the 9. We can simplify this fraction. We'll divide both by 20, so L will be 7/18 times pi times the 18. And then you can see these 18s will cancel. So the arc length will be 7 pi. But to work out the perimeter, we need to include each of these radii. So the total perimeter will be the arc length plus the 2 radii. And that's in centimeters. Okay? Let's try an exam style question. So now we're told that OAB, this sector here, has center O, and OCD, this sector, has the same center, and OCA, ODB are both straight lines. The angle is 135, and then O to D is 6, and D to B is 4. We need to work out the perimeter of this composite shape. If you want to give this question a go, you can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So the way I'm going to do this is I'm going to break it up into different parts. We'll have the first part, which is the sector of AB. Then we'll have the arc length from C to D. And to this, we'll add the length A to C and D to B. So if we begin with this arc length, we know the angle is 135, and the radius would be the 6 plus the 4, so the radius will be 10. And then the arc length would be the angle 135 over the 360 multiplied by pi times the diameter. And if the radius is 10, the diameter will be 20. So we can simplify this. We'll divide both by 45, and we get 3/8 of pi multiplied by the 20. So this will give us 60 pi over 8, which we can simplify as 15 pi over 2. If we move on to the smaller arc length, we'll have the same angle of 135, but now the radius is the 6 centimeters. So on this arc length will be the same fraction of a circle, which we simplify to make 3/8, times pi, times the diameter of 12. So we'll get 3 times 12, 36 pi over 8, which we can simplify, divide both by 4, and we get 9 pi over 2. So the total perimeter would be the blue arc length, 15 pi over 2, plus the red arc length, 9 pi over 2, plus this length, which we know is 4, and this one, which is also 4, so plus 8. If we add these two together, we'll get 24 pi over 2, which is 12 pi, plus the 8 centimeters. And to give this as an answer to 3 significant figures, we can go to our calculators. We'll enter 12 pi plus 8, and we get 45.7 centimeters to 3 significant figures. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.